Welcome to the first session on decimal numbers. In this session, we will discuss what are decimal numbers, the types of decimal numbers, their properties, and operations on decimal numbers. In this session, our discussion will be limited to addition and subtraction of decimal numbers. However, in the upcoming sessions, we will talk about multiplication and division of decimal numbers and the word problems based on decimal numbers. This year, however, there was a direct question on decimal numbers which was based on addition and subtraction. The topic is very simple. You just have to be a little careful. Let us begin. Decimals. The numbers which are expressed in decimal forms are called decimals or decimal numbers. Example: 6.8, 16.73, 7.364, 0.053. These are the example of decimal numbers or decimals. Let us understand a little deeper. A decimal number has two parts. They are the whole number part and the decimal part. Whole number, we know, are the numbers which start from 0, 1, 2, 3 and they go till infinity. So in this decimal number, one of the part is the whole number part and another part is the decimal part. These two parts are separated by a dot and this dot is called the decimal point. The part on the left side of the decimal point is the whole number part and the part on the right side of the decimal point is the decimal part. Let us look at an example: 73.62. Decimal point is at the center. The left hand side is 73. This is the whole number part. And the part which is on the right side of the decimal point is called the decimal part. So in this way, we can see that a decimal number is a combination of a whole number and a decimal part. Here 73 will represent the whole number part and 0.62 including the decimal point will include the decimal part. After the decimal numbers, let us understand another important part, which is decimal places. The number of digits contained in the decimal part of the decimal gives the number of decimal places. Let us understand this through an example. The example is 5.74. Here, the decimal part is 0.74. This is the decimal part. And in the decimal part, we have two digits, namely 7 and 4. Now, since in the decimal part we have two digits, then we can say that this decimal number 5.74 has two decimal places. So to understand what are decimal places, it is the number of digits in the decimal part. 8.536. Here in the decimal part there are three digits. So I can say that it has three decimal places. So decimal place means the number of digits in the decimal part. 2 digits means 2 decimal places. 3 digits means 3 decimal places. A very important concept, because when we compare the decimal numbers or when we multiply the decimal numbers or when we add the decimal numbers, these decimal places play an important role. To summarize decimal places, the number of digits in the decimal part is the decimal places. Like decimals, the decimals having or decimal numbers having the same number of decimal places are called like decimals. For example, 6.73 has 2 decimal place. Decimal place I am writing in short DP. So I'll write DP, you understand this as decimal place. So 6.73 has 2 decimal place. Similarly, the next decimal number 8.05 also has 2 decimal place. The next decimal number 19.68 also has 2 decimal place. So the decimal numbers having the same decimal places are called like decimals. To summarize, like decimal means the decimal number will have same decimal places. All of them. If one number has 2 decimal place, then other numbers will also have 2. So they will be called as like decimals. Now, unlike decimals. Unlike decimal means the decimals having different number of decimal places. For example, the first number here 5.3 has 1 decimal place. Second example, second decimal number 8.64 has 2 decimal place. And the third decimal number 10.023 has 3 decimal place. Now since all these 3 decimal numbers have different decimal places, namely 1 decimal place, 2 decimal place and 3 decimal place, we will call them unlike decimals. So same decimal places, like decimal, different decimal places, unlike decimals. One of the very important point to understand about decimal numbers and their decimal places, putting any number of zeros to the extreme right side of the decimal part of a decimal number does not change the value. What does it mean? It means 3.8, 3.80. Now what I have done, I have placed a 0 on the right side of the decimal part number 8. And if I write one more 0, so this is 3.8, 3.80, 3.800. Understand that numerically they all are equal. Their value is same. However, their decimal places are different. Now we can use this method to actually make the decimal places of unlike decimals same. How do we do that? We will learn this in one of the question while comparing the decimal numbers. But understand that if you place a 0 on the right side of a decimal part, it will not change the value. The value remains same. For example, 2.7, 2.70, 2.700 or 2.7000. This is first number is 2.7, second is 2.70, third is 2.700 and fourth is 2.7000. Numerically they all are equal. However, the only difference is they have different decimal places. So their value is same. That is what this point is explaining, and it can be asked in the exam in a true false type of question, that will adding a 0 on the right side of the decimal part, will it increase the value of the decimal number? Answer is no, it will not increase. It will only increase the decimal place. Now friends, as we have an Indian place value system and an international place value system, we also have a place value chart for the decimal numbers. The place value chart of decimal number, we have a decimal point at the center, and remember, on the left hand side it is the whole number, the places for whole number will be similar to what we have for our natural numbers, which will be ones place, tens place, hundreds place, thousands place. It will move ahead. And for the decimal part, which is on the right side, our places value, the first number on the right of the decimal part will be tenths place. Remember, it's not tens, it is tenths place. The second digit will be hundredths place. The third digit will be thousandths place. Now remember, this is not tens, hundreds and thousand, it is tenths with the THS, hundredths, thousandths. This is the place value chart of a decimal number. We'll understand it better when we will do one question of comparison of decimal numbers. Comparing decimals. Suppose we have to compare two decimal numbers. Then what are the steps? In the first step, we have to convert the given decimals or decimal numbers into like decimals. Means we have to make the decimal places same. Next step, first we compare the whole number part. The decimal with the greater whole number part will be greater. If the whole number parts are equal, then we compare the tenth digit. The decimal with the bigger digit in the tenth place will be greater. And next step will be, if the tenth digit is also equal, then we compare the hundredth digit. If the hundredth digit is also equal, then we compare the thousandth digit. Let us understand the first step. For this, we will take an example. 5.74, 2.1. So to compare these two decimals, which are right now unlike decimals, because in the 5.74 I have two decimal places, and in 2.1 I have one decimal place. So the first step of comparing them will be to convert these two unlike decimals to like decimals. Now, how to convert an unlike decimal to like decimal is by adding zeros. On the right side in the decimal part, the first number is 5.74, which has two decimal places. The second number is 2.1, which has one decimal place. So to convert this 2.1 from one decimal place to two decimal place, I will place a 0 on the right side of 1. Now my number 2.1 becomes 2.10, and now both the decimal numbers have same decimal places, which means both have two decimal places, and now they are like decimals. Now, since they are like decimals, the first step of comparison will be the whole number part, which is the left side part. The number which has a greater whole number part will be greater. When I observe that in 5.74 and 2.10, 5 is greater than 2. The whole number 5 is greater than whole number part 2. So I can say that 5.74 is greater than 2.10 or 2.1. 5.74 is greater than 2.1. That was the first step of comparing the decimal numbers. We have to first convert unlike decimal to like decimal by adding zeros in the decimal part, and then we start comparing the whole number part. Now, the step 2 says we have to compare the whole number part to find out which decimal number is greater. Let us go to the step 3 and understand what to do when the whole number parts are equal. The rule says that we compare the tenths place. Let us understand this through an example. 6.583, 6.24. Here my two decimal numbers are 6.583, which has 3 decimal places, and another decimal number 6.24 has 2 decimal places. So first I will convert them from unlike to like decimals, and for this conversion I will add a 0 to the second decimal number 6.24, and I will add the 0 at the right side. Now both the decimal numbers have equal decimal places. Now since they are equal decimal places, now they are like decimals, and the comparison of like decimals will start from the whole number part. Let's compare the whole number part. The first number whole number part is 6. The second number also the whole number part is 6. Remember, when the whole number part is same, then we compare the tenths part. The tenth part of the first number 6.583 is 5. The tenth part of the second number 6.240 is 2. I know that 5 is greater than 2. So in the tenth part I find out that the tenth place of 6.583 is 5 and the tenth place of 6.240 is 2. Comparing them, I find that 5 is greater than 2. So the number 6.583 will be greater than 6.240. Remember, 6.240 is originally 6.24. So 6.583 will be greater than 6.24. This is the easiest way of comparing the unlike decimal numbers or per se decimal numbers. Now, we have seen an example of comparing the decimal numbers using the whole number part, using the tenth part, and now let us take an example to understand what to do if the tenths place is also same. For this, I'll take an example. 7.8215, 7.8413. Now here in these two decimal numbers, the decimal places are 4 decimal places. They both have same decimal places, so no need of converting them because they are already like decimals. And now let's start comparing. First, the whole number part. Whole number part in both the decimal number is 7 and 7, so they are equal. We cannot compare them based on the whole number part. Let's go to the tenth place. The tenth place in both the decimal number is 8 and 8, so they are same. When the tenth place is same, we go to the hundredths place. The first decimal number hundredths place is 2. The second decimal number hundredths place is 4. So we see that the hundredths place of the first decimal number is 2 and the hundredths place of second decimal number is 4. Clearly 2 is less than 4. So the first decimal number will be smaller than the second decimal number. Per se, 7.8215 will be smaller than 7.8413 based on the comparison of hundredths place. And if suppose the hundredths place is also similar, then we go to the thousandths place. This is how we compare the decimal numbers. I hope the concept is clear. It will be further more clear when we will solve some problems based on this, which is upcoming. Write the following decimals in ascending order. The decimal numbers are 5.74, 6.03, 0.82, 0.8, 0.658 and 7.2. Now, if we want to write these decimal numbers in the ascending order, then first I have to compare them. On comparison, I see that the first number 5.74 has 2 decimal place. The second number 6.03 also has 2 decimal place. The third number 0.8 has 1 decimal place. The fourth number 0.658 has 3 decimal place. And the fifth number 7.2 has 1 decimal place. So I see that right now they are unlike decimals. And first, if I want to compare them, I have to convert them from unlike to like decimals. Now for converting them to like decimals, you give them the number of decimal places which is the highest decimal places. Here the fourth number 0.658 has 3 decimal place. So I have to give 3 decimal place to every decimal number. And how to give a decimal place? Very simple, by adding 0 on the right side. The first number 5.74, right now it has 2 decimal place, so place one more 0, it will have 3 decimal place. 6.03 has 2 decimal place, place a 0 on the right side of 3, it also has now 3 decimal place. 0.8 has 1 decimal place, so I have to write down 2 zeros on its right side to give it 3 decimal place. 0.658 is already 3 decimal places, so I don't have to write anything. 7.2 has 1 decimal place, so I will write 2 zeros on the right side of 2 to make it 3 decimal place. Now all the numbers are having the same decimal place, so they are now like decimals. Now let's start comparing. Ascending order means I have to write down from smallest to greatest. For comparison, let's start comparing the whole numbers. 5, 6, 0, 0 and 7. So among them the smallest should be 0 and 0. So there are 2 decimal numbers which are starting with 0. So how to compare them? Let's go to their 10th place. The 10th place of 0.800 is 8 and the 10th place of 0.658 is 6. I know that between 8 and 6, 6 is smaller. So this number 0.658 will be the smallest. After 0.658 should come 0.800. Now remember that 0.800 is actually 0.8. So I will not write it as 0.800, rather I will write it as 0.8. Since we have done the comparison, no need of keeping 3 decimal places. So these 2 numbers have been arranged. Now let's go to the other 3. Among 5, 6 and 7, the smallest is 5.740, since 5 is the smallest whole number. So this is the smallest decimal number. Let's write 5.74. Now again, I am not writing the 0 which I have written for making the decimal places same. I am ignoring that because I know that 5.740 is the smaller, so no need of keeping this 0 anymore. After 5.74, it should be 6.03 and finally 7.2 will be the greatest. This is the order of comparison. The concept is very simple. Now coming to the most important part, convert each of the following decimals into a fraction in its simplest form. Now understand 0.5. Now here 0.5 has only a decimal part. there is no whole number part. There's nothing on the left side of the decimal point, so there's no whole number part. Now remember, there is no whole number part. You can write on your own a whole number 0 here, just for your sake of convenience. So 0.5 actually means 0.5. Remember, when there is no whole number part, you can give yourself a whole number part which can be 0. And 0.5 and 0.5 are same. There is no difference. They are equal. The question says to convert 0.5 into a fraction. Now remember, if you want to convert a decimal number into a fraction, then always count the decimal places. In 0.5, after the decimal there is one digit. So one digit after the decimal point means one decimal place. And now friends, remember, if after the decimal point there is one digit, or if there is one decimal place, then first you remove the decimal. If I remove the decimal, this number will be only 5. Very important step. First you remove the decimal. When I remove the decimal, this number is now only 5. And now the most important step, go to the denominator and place 1. Go to the denominator and place 1. And after this 1, place as many zeros as the decimal place. Here in this decimal number there was one decimal place, so after 1 in the denominator, place 1 0. So one decimal place, so 1 0 in denominator. So now my number 0.5 becomes 5 upon 10. The question is also asking to convert it into simplest form. Now to convert 5 upon 10 to its simplest form, what I am going to do is, I know that both 5 and 10 are divisible by 5, so I will divide them both by 5. 5 divided by 5 will give me 1 in the numerator, and 10 divided by 5 will give me 2 in the denominator. So 5 by 10 in the simplest form becomes 1 by 2. Rather, I can say that 0.5, decimal number 0.5 in the simplest form of fraction becomes 1 upon 2. This is our answer. Let us understand it better through some more examples. Convert each of the following decimals into a fraction in the simplest form. Second example, 0.24. Here, in the decimal part, we have 2 digits after the decimal point. 2 digits in the decimal part means 2 decimal places. And to convert a decimal number with 2 decimal places into a decimal fraction, first remove this decimal point, it will become 24. And in the denominator, first write down 1. And after 1 on its right side, since there are 2 decimal places, you have to write 2 zeros. So 2 decimal places, 2 zeros. So remember, in the denominator after 1, number of zeros will be equal to the number of decimal places. Now 24 and 100, they both are even numbers. Let us divide both of them by 2 to convert them into the simplest or the lowest form. When we divide 24 by 2, I get 12. When I divide 100 by 2, I get 50. So now it becomes 12 upon 50. I see here that both 12 and 50 again are even numbers, so both will be divisible by 2. Let's further divide them by 2. 12 divided by 2 will give me 6. 50 divided by 2 will give me 25. So 6 upon 25. This is further no conversion to simplest form is not possible. So this is our final answer. So 0.24 into the simplest form becomes 6 upon 25. Third example, converting each of the following decimals into a fraction in the simplest form. Third example is 0.08. Here I have two decimal places. So first I will write down this number without the decimal point. Without the decimal point it will become 0.8. And remember, 0.8 is actually only 8. So my numerator will be 8. And in the denominator, first I will write 1. Here there are two decimal places, so I will write two zeros after 1. 8 and 100, they both are divisible by 2. In fact, we can divide them directly by 4, but for the sake of convenience, I will first divide them by 2. 2 4s are 8. 2 50s are 100. 4 upon 50, again both are even numbers. We can divide them by 2. 2 2s are 4. Dividing 50 by 2, I get 25. So my answer is 2 upon 25. The decimal 0.08 when converted to fraction in the lowest term becomes 2 upon 25. Next example. .225. Here, after the decimal point, I have 3 decimal place. So first write this number without the decimal point, it will become 225. And then in the denominator after 1, since there are 3 decimal places, after 1 I will write down 3 zeros. Now both 225 and 1000 are divisible by 5. Let's divide 225 by 5. 5 4s are 20, to carry 5 5s are 25. So when I divide 225 by 5, I get 45 in the numerator. And let's divide denominator 1000 by 5. This will be 5 2s are 10, place 2 zeros, becomes 45 upon 200. Now both of them are again divisible by 5. Let's divide them by 5. It's 5 9s are 45. 5 4s are 20, place a 0. Answer is 9 upon 40. So 0.225, when we convert it into the fraction in the lowest form, becomes 9 upon 40. Convert each of the following into a decimal fraction. The first example is 27 upon 4. This is a fraction right now. Now I have to convert it into a decimal fraction. For converting this into a decimal fraction, I will divide the numerator 27 by the denominator 4. Let's start the division. Now I know that my divisor is 4, my dividend is 27. I'll take the first number 2. 4 will not go into 2, so I'll have to take the first 2 digits, 27. In 27, 4 will go 6 times. 4 6 ja 24. On subtracting, I get 3. Now I know that 4 will not go in 3. So I have to increase this 3. And how to increase the 3? We can increase any number only by adding 0 on the right side. Now, The rule of adding the 0 is we have to add a decimal point after 6, and when we add a decimal point after 6, then we can place a 0 here. Now my number becomes 30. In 30, 4 will go 7 times. 4 sevens are 28. Subtracting, I get 2. Now 4 will not go in 2. So again I have to increase 2. And for increasing the 2, I'll place a 0 on the right side. Now remember, the adding or placing a 0 on the right side involves adding a decimal point. But since we already have added a decimal point, no need of adding the decimal point again. If we have already placed a decimal point in the quotient, then you can add as many zeros as you want, but only once. 20. 4 will go in 20 5 times. 4 5s are 20. My division is complete. My quotient is 6.75. So 27 upon 4 in decimal number becomes 6.75. And now remember, 6.75 has 2 decimal places. To convert it into a decimal fraction, remove the decimal point and write down this number without the decimal point. It will become 675. 6.75 has 2 decimal places. So in the denominator, first write down 1. And for 2 decimal places, write down 2 zeros. So 6.75 is actually equal to 675 upon 100. I will explain this one more time. हमें अगर 27 को 4 से डिवाइड करना है और उसे डेसिमल नंबर में कन्वर्ट करना है, तो सबसे पहले हम 4 6 जा 24 लेंगे. सब्ट्रैक्ट करने पर 3 आ गया. अब 3 में 4 नहीं जाता है, तो हमें इस 3 को बड़ा करना होगा. बड़ा करने के लिए हमें यहाँ पर 0 लगाना होगा, और ये 0 लगेगा तब जब हम क्वोशंट में 6 के बाद एक डेसिमल पॉइंट लगाएंगे. 6 के राइट साइड में एक डेसिमल पॉइंट लगा और 3 के राइट साइड में हमने एक 0 लगा दिया. दिस इज द रूल ऑफ एडिंग 0. ये 0 को ऐड करने का रूल है. ऊपर एक डेसिमल पॉइंट, यहाँ पर एक 0. 30 में 4 7 टाइम्स जाएगा. 4 7s are 28. माइनस किया, 2 आ गया. 2 में 4 नहीं जाता है. अगेन हमें 2 को बड़ा करना पड़ेगा. हमें यहाँ 0 लगाना पड़ेगा. नाउ रिमेंबर, एक चीज़ आपको याद रखनी है कि अगर हमने एक बार डेसिमल पॉइंट दे दिया है तो एक 0 हम हमेशा लगा सकते हैं. 2 0 हम नहीं लगा सकते. एक साथ 2 0 नहीं लगेंगे. जैसे 2 को 200 नहीं बना सकते. 2 को एक बार में हम सिर्फ 20 ही बना सकते हैं. सो एट अ टाइम हम एक ही 0 ऐड कर सकते हैं. अगर हमने एक बार डेसिमल पॉइंट ऐड कर दिया तो एक अकेला 0 हम एट अ टाइम ऐड कर सकते हैं. 2 0 हम एक साथ नहीं लगा सकते. उसके लिए हमें न्यूमरेटर में भी 0 लेना होगा. दैट वी विल सी. जब ऐसे हमारे पास एग्जाम्पल्स आएंगे देन वी विल एक्सप्लेन दैट. 20 में 4 विल गो 5 टाइम्स. विल से 4 5s are 20. डिवीजन कंप्लीट हो गया. 27 अपॉन 4 की वैल्यू 6.75 आ गई है. नाउ अंडरस्टैंड, 6.75 इज अ डेसिमल नंबर विथ 2 डेसिमल प्लेसेस. और इसको अगर आपको एक फ्रैक्शन में लिखना है तो हम बिना डेसिमल पॉइंट के इसे 675 कहेंगे. डिनोमिनेटर में पहले 1 लगाएंगे और बाद में 2 डेसिमल प्लेस है तो 2 zeros ऐड करेंगे. तो फ्रैक्शन में ये हो जाएगा 675 अपॉन 100. डेसिमल में ये हो जाएगा 6.75. नेक्स्ट एग्जाम्पल, convert each of the following into a decimal fraction. The second one example, 2 whole 5 upon 8. Now remember, in this 2 whole 5 upon 8, 2 is the whole number part. So don't touch it. Leave it as it is. And only operate the fractional part, which is 5 upon 8. Here, I'll divide 5 by 8. Now remember, 8 will not go in 5, so I have to increase the 5. To increase the 5, first put a decimal point in the quotient. And since we have placed decimal point in the quotient, I will place a 0 after 5. So in the first step itself, I have to increase 5 to 50. To increase 5 to 50, I have placed a 0 on the right side of 5, and this 0 has come against the decimal point in the quotient. Now in 50, 8 will go. 8 6 ja 48. Subtracting, I get 2. Now 8 will not go in 2. It means I have to increase the 2. Place a 0 on the right side. Now, as we have already placed a decimal point in the quotient, I do not have to again do anything else, but simply I can add 1 0 here. So 2 will become 20. Now in 20, 8 will go 2 times. 8 2s are 16. Subtracting, I get 4. Now 4, 8 will not go in 4, so I have to increase this 4. I already have a decimal point in the quotient, so I can place a 0 here. In 40, 8 will go 5 times. 8 5s are 40. My division is complete. My answer of 5 upon 8 is 0.625. Now remember, my actual number was 2 whole 5 upon 8. So write the 2 as it is. And after that, my fractional part gave me 0.625. Write it after 2. It will become 2.625. Remember, my whole number value 2 will remain as it is. I will only divide 5 by 8, which will give me 0.625. Together it will become 2.625. So 2 whole 5 upon 8. In decimal, it will become 2.625. Now if you want to convert this into a decimal fraction, remember 2.625 has 3 decimal places. So now write down this number without the decimal point. It will become 2625. In the denominator, write 1. For 3 decimal places, add 3 zeros on the right side. It will become 2625 upon 1000. My final answer. Convert each of the following into a fraction in the simplest form. First example is 0.8. Now in 0.8, I have 1 decimal place. Write down. Without a decimal point, it will become 8. And in the denominator, after 1, place 1 0. It will become 8 upon 10. Both 8 and 10 are divisible by 2. Convert them into simplest form by dividing them by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So 0.8 becomes 4 upon 5. Second example, 0.75. 0.75 has 2 decimal places. Write down this number without the decimal point. It will be 75. In the denominator, write 1. For 2 decimal places, write down 2 zeros after 1. It will become 75 upon 100. Both 75 upon 100 can be converted to lowest form either by dividing by 5 or 25. For the sake of easiness, I will divide them by 5. 75 divided by 5 is 15. 100 divided by 5 is 20. 15 upon 20 can again be divided by 5. 15 divided by 5 will give me 3 in the numerator. 20 divided by 5 will give me 4 in the denominator. So 0.75 finally becomes 3 upon 4, the fraction in its lowest form. Third example, 0.06. It has 2 decimal places. 2 digits after the decimal point, it has 2 decimal places. So first I will write this number without the decimal point. It will become 06. And remember, 06 is actually only 6. So my numerator will be 6. And in the denominator, first I will write 1. It has 2 decimal places, so I'll place 2 zeros after 1. It becomes 6 upon 100. Now both 6 and 100 are divisible by 2. Let's divide them by 2. 6 divided by 2 is 3. 100 divided by 2 is 50. It will become 3 upon 50. So 0.06 becomes 3 upon 50. Next, 0.285. There are 3 decimal places. First I will write down this number without the decimal point. It will become 285 upon. In the denominator, first I will write down 1. And since there are 3 decimal places, I'll write down 3 zeros. It will become 285 upon 1000. Let's divide both of them by 5 because they both are divisible by 5. Let's divide them by 5. 285 divided by 5 is 5 5s are 25. Carry 3. 5 7s are 35. So this will become 57 upon 1000 divided by 5 is 5 2s are 10. Place 2 zeros. 200. 57 upon 200 cannot be further simplified into lowest form. So this will be our final value. 0.285 will be 57 upon 200 in the simplest form. Convert each of the following into a decimal. First example, 47 upon 10. 47 upon 10 is a decimal fraction, and if I want to convert them into a decimal number, look at the number of zeros in the denominator. In the denominator, after 1 there is 1 0. So in the denominator there is 1 0. Remember, when there is 1 0 in the denominator after 1, then you go to the numerator 47, and from the right side count 1 digit. Why we are counting 1 digit? Because in the denominator there is 1 0. So 1 0 in the denominator will lead to counting 1 digit from the right side of the numerator 47. Count 1 digit. 1 digit from the right side is 7. After 7, put a decimal point. It will become 4.7. 47 upon 10 becomes 4.7 in the decimal form. Convert 156 upon 100. It is a decimal fraction. We have to convert it into a decimal number. When you look at the number of zeros in the denominator, 100 has 2 zeros. Now since 100 has 2 zeros, we go to the numerator 156, and from the right side we will count 2 digits. Now why we will count 2 digits? Because in the denominator 100 there are 2 zeros. So if the denominator has 2 zeros, from the right side in the numerator you count 2 digits. Right side 2 digits, first 6, second is 5. After counting 2 digits, place a decimal point. It will become 1.56. So 156 upon 100 becomes 1.56. Third example, 2516 upon 100. In the denominator 100, I have 2 zeros. So now I'll go to the numerator 2516, and from the right side I will count 2 zeros. So since the denominator has 2 zeros, I will count 2 digits. 2 digits from right side will be 6, 1, put a decimal point. My answer is 25.16. So 2516 upon 100 will give me 25.16 in the decimal number. Similarly, the fourth example, 3524 upon 1000. 1000 has 3 zeros. Now since 1000 has 3 zeros, I'll go to the numerator 3524 and from the right side I'll count 3 zeros, so 3 digits. From the right side, the first digit is 4, second digit is 2, third digit is 5. After counting 3 digits, I will put a decimal point. It will become 3.524. So 3524 upon 1000 becomes 3.524. I have to convert 25 upon 8. The fraction 25 upon 8 to decimal number. For this, we will divide 25 by 8. 8 will go in 25 3 times. 8 3s are 24. Subtracting, I get 1. Now 8 will not go in 1, so I'll have to increase 1. We can increase 1 by placing a 0 here. And this 0 will come here after placing a decimal point in the quotient after 3. So after 3 I put a decimal point, and after 1 I place a 0 against that. Now 8 ones are 8. Subtracting, I get 2. Now 8 will not go in 2. I have to increase 2. To increase 2, place a 0 here. Now remember, since we already have placed a decimal point in the quotient, no need of placing one more decimal point. Once you have a decimal point in the quotient, you can add as many zeros as you want, one at a time only. So now my number becomes 20. 8 will go in 20 2 times, as 8 2s are 16. Subtracting, I get 4. 8 will not go in 4. I have to increase 4. To increase it, place a 0 here. And in 8, 40. In 40, 8 will go 5 times. 8 5s are 40. Division is complete. My quotient is 3.125. That is our final answer. 3 whole 2 upon 5 to be converted to a decimal. Now remember, in 3 whole 2 upon 5, 3 is the whole number part. Don't touch it. Keep it as it is. And we will only divide 2 upon 5. And later we will write them together. Let's divide 2 by 5. Now 5 will not go in 20, so I have to increase 2. To increase 2, we have to put a decimal point in the quotient, and against this decimal point I can write down a 0 after 2. It will become 20. So in the quotient I put a decimal point, after 2 I put a 0. Now in 25 will go 4 times. 5 4s are 20. Division is complete. My quotient is 0.4. So when I divide 2 by 5, I get 0.4. And here the whole number part is 3. Let's write them together. Whole number part 3, write down first. And then 2 by 5 gives me 0.4. So represent like this. It will become 3.4. So 3 whole 2 upon 5 will become 3.4. Now remember, I have not done anything to the whole number part. I have kept it same. I have only divided 2 by 5, which gave me the answer as 0.4, and I have just written it after the whole number part. Writing them together, my answer becomes 3.4. 2 whole 2 upon 25. We have to convert this mixed fraction to a decimal number. Remember, 2 is the whole number part. We will not touch it. We will keep it as it is. We will only operate at the fraction part, which is 2 upon 25. Let's divide 2 by 25. Now 25 will not go in 2. So I have to increase this 2. I have to make it 20. And for that, I'll put a decimal point in the quotient. When I will put a decimal point in the quotient, I can write a 0 after 2. Now 2 becomes 20. But our problem is not solved here. Still 25 will not go in 20. So now I have to further increase this 2, which is already increased to 20. I have to further increase it. And friends, remember a very important point. First we have increased 2 by adding a decimal point, and against that I have placed a 0 here, but that is still not solving my problem because 20 is still smaller than 25. It means I have to further increase it. And if you want to increase it 2 times, means if increasing it means increasing will happen only by adding zeros. So here I have to add 2 zeros at a single time, at a single instance. When I have to increase, or when I have to add 2 zeros, then 1 0 will come against the decimal point, but for another 0 at the same step, when we want to add 2 zeros, 1 will be taken from the decimal point and another 0 will be, you have to add a 0 here. So remember this case, जब एक 0 लगाने पर भी नंबर हमारा बड़ा नहीं हो पाता है तो हमें एक और 0 चाहिए, और एक और 0 अगर आपको चाहिए, अगर एक ही स्टेप में आपको 2 0 चाहिए, तो एक 0 तो आपको डेसिमल से मिलेगा और दूसरे 0 के लिए आपको क्वोशंट में एक 0 लगाना पड़ेगा. और अब हमारा ये नंबर 200 हो चुका है. इन 200 25 विल गो 8 टाइम्स. 25 8s are 200. My division is complete. My quotient is 0.08. So 2 upon 25 will give me 0.08. This is the decimal part, and my whole number part is 2. Let's write them together. This will become 2. Decimal part will be 0.08. This is my final answer. 2 whole 2 upon 25 will become 2.08.